Hi everyone. The commercials for the iPod Shuffle said, "Life is random." But what exactly is randomness? We're exploring that a bit in this activity, the iPod Shuffle activity. And it's important partially because what we're interested a lot is what we're seeing the result of randomness? Just randomness acting alone? Or is there something else happening? That was Albert Hoffman's question when he looked at how many songs by the same artist he saw on his playlist. He thought that too many songs were occurring by the same artist, and that meant that the iPod Shuffle wasn't random. But is that what randomness means? So what did Albert Hoffman do in our real world? He's wondering whether the iPod Shuffle is really a random process. So he repeated it several times. He generated these 3 playlists with 20 songs each. He was thinking about the number of songs by the same artist. There's lots of features of these playlists he could have been looking at, but he was really focused on the number of songs by the same artist. And he wondered, are more songs by the same artist being played than we would expect under randomness? But it's a little disingenuous, in fact, to present this as a question, because Albert Hoffman really made up his mind already. He just already knew this. I'm not sure whether he even asked himself this question. He just thought it was true. And why did he do that? What was his process coming to that? He was looking at the real world, but he wasn't using a simulated world to evaluate it. He was using what I'll call the intuitive world. So in the intuitive world, we have this sense of things that seem random. And we look at the results that we see in the real world, and we ask ourselves, does this fit with what seems random? And often this process happens very, very fast, and we make a decision based on that bears on our understanding of the real world. Instead, you did something different. We generated for you, we created a random model, we repeated the process, and you saw the results of the process with the 20 song playlists, and you looked at 25 random playlists and then 5 more after that to sort of develop rules and evaluate several trials. We wanted you to focus on the number of songs by the same artist because that was really Albert Hoffman's concern. But people also looked at a bunch of other features of the playlist to try to flag what randomness would or wouldn't mean based on the random playlist that we generated for you. And you know what? Most of you actually thought that Albert Hoffman was basically wrong, because you saw that in the random playlists there were often up to 5, and in a couple cases even 6 songs by the same artist on a playlist. And then you compared that with Albert Hoffman's playlists, and he didn't have any over 6. I believe he had one playlist that had 6 by the same artist on that. So part of what we wanted you to think about with this is how comparing the real world with your intuitive world is a little different than comparing it with the simulated world. Because what's the origin of things that seem random? What drives us to think something that seems random? There's a couple features of it. We like to see no clumps in the data. We don't like to see big bunches of the same thing, like a whole bunch of heads when you're flipping a coin. We don't like to see any patterns in the data if they're patterns that really seems non-random to us. And we want randomness to kind of even out over time. We don't want things to get too imbalanced. If the chances of heads are 50-50, we should kind of get closer and closer to 50-50 over time. So let's examine each of these in turn. No clumps. No clumps in the data. We already know this from the Fun Science video, of course. Randomness has lots of clumps, way more than we expect. You saw that when you had the person flipping a coin versus the person making up sequences of heads and tails. There was a lot more clumps in the randomness than in the human-generated one. Let's think about no patterns. We see patterns everywhere. We see them in the clouds. We see them on the static in a TV. Seeing a pattern is actually pretty common, even in something randomly generated. No matter what's generated, we'll probably be able to find some sort of pattern in there. So seeing a pattern doesn't really necessarily tell us much about whether it's random or not. Now let's think about this concept of evening out. We also saw that in the Fun Science video when he was talking about how the roulette wheel, I believe it was roulette, came up the same color over and over again. So he bet lots of money on the other color. And then it came up that same color again. So that gets this idea that randomness has no memory. If you flip a coin 100 times and get 100 heads, chances are still 50-50 that you'll get heads the next time. One thing that is true, let me just make one comment on this, is if you flip it more and more times, the overall average will expect that to approach 50, but any given time that we flip a coin, we're going to have the same chances of getting heads and tails. So things that seem random, these intuitions that drive something seeming random to us, they're all upside down. And that's why we need statistics. That's what can be so tricky about randomness. We start out all upside down. But don't worry, we figured out a few tricks to turn everything around in statistics. Thanks for listening, and look out for a video in the next couple days for the one sun activity.